became apparent that we had to find some different technology because helicopters do everything by brute force. We needed something with a little more finesse that gave us additional range, payload, and speed.
The primary mission for the Marines is as an early strike force, and the solution to their requirement was this: a part helicopter, part fixed-wing airplane called the V-22, V as in vertical. Its nickname is Osprey, a powerful hawk able to hover over its prey and strike like an arrow. The V-22 Osprey will give the Marines an important tactical advantage they call over-the-horizon maneuvering.
The proliferation of enemy weapons means that the ships that we operate from in the Marine Corps can't come in as close to the beach.
With the V-22, the Marines can stay hidden behind the curvature of the Earth, roughly 25 miles offshore. That gives them the protection of being over the horizon in the beginning phases of a conflict.
We use maneuver as a weapon, much like a chess player does. Hit them where they ain't is the football term.
The V-22 is known as a tilt rotor for obvious reasons. The rotors and their engine housings, called nacelles, one on each end of a fixed wing, can be tilted 90 degrees up or down. When they are down, the Osprey flies like an airplane. When they are up, it flies and hovers like a helicopter. The idea for this hybrid helicopter airplane has been around for many years, but as usual, theory preceded available technology. Bell Helicopters flew its first prototype tilt rotor, the XV-3, in 1955. In the 60s, the military took an active interest in tilt rotors, having learned not only the helicopter's value in Vietnam, but also its limitations.
The thing that you can't do with a helicopter is get long distances with good payloads for any extended period of time.
The military mission was clear, and with the basic aerodynamics proven, it was time to tackle the technology. One chief concern was the exceptional amount of power needed as the tilt rotor transitioned from helicopter to airplane. Piston-driven combustion engines in early models were too big and heavy to do the job well.
We didn't have the technologies in hand to build a tilt rotor that had any utility other than to fly. It couldn't carry payload. It was too heavy.
The solution came with the advent of much lighter and more powerful turbine engines. The advanced design of the turbine engine became an essential component of the next prototype, the XV-15.
And this allowed the turbine technology and tilt rotor technology to be combined. Extremely successful program. In fact, those aircraft are still flying today.
But even with lighter turbines, weight was still a problem for the V-22. Designers replaced many heavier metals in the fuselage, wing, and rotors with lighter and stronger composites of graphite, fiberglass, and other materials. That reduced not only weight, but also corrosion and cost. The next obstacle was in the flight control systems. The control mechanisms of airplanes and helicopters are different. They are not compatible for a smooth transition from helicopter to fixed-wing flight.
Let me give you an example. The rotor system on the tilt rotor in the hover mode operates very much like a tandem rotor helicopter. The rotors will lift and will tilt back and forth in order to control the aircraft in space. However, as the aircraft begins to move forward and move into the airplane mode, these controls gradually phase out. And airplane control surfaces, ailerons, rudders, and elevators control the aircraft when it's in the airplane mode. And when it comes back to the helicopter mode, the controls come back in and take over, and they become the primary control for the aircraft.
The solution was to replace mechanical linkages with a computerized control system, linking the pilot's controls in the cockpit to flight control systems throughout the aircraft. It is called fly-by-wire, and this is what it means to a pilot.
This thumb wheel switch right here, which the pilot activates with his left thumb, becomes the most powerful controller in the aircraft. With this controller, I can rotate my nacelles down to airplane mode or rotate them back to the helicopter mode.
Fly-by-wire made the V-22 Osprey much easier for a pilot to fly, setting the stage for a truly functional tilt-rotor aircraft.
It was not until we had added the other two technologies of fly-by-wire controls and composite materials to the turbine engine and tilt rotor technologies, and that is what has led to the successful V-22 program that we have today.
Maneuverability is another important aspect of the Osprey. It can hover, do turns around a point, fly sideways and backwards, and within a matter of seconds be flying as an airplane at almost 300 miles an hour. A remarkable feat considering the size of the V-22. In fact, it takes only 12 seconds for it to convert from hover to full-flying turboprop airplane. But it would still take one more component to bring it all together: the glass cockpit, an array of computer-controlled displays.
In front of us now you see what we call the multi-function displays, the MFDs, a glass cockpit. This is the information that's displayed to the pilot that allows me to fly it. I can read my airspeed, my altimeter, my radar altimeter, vertical speed. Condensed in this one 8x8 square is all the information the pilot needs to fly the aircraft, keep it upright, and to go down range.
The glass cockpit means greater awareness of the flight environment for the pilot and crew. Also, the V-22 is the first rotorcraft with true anti-ice and all-weather capabilities. These features make flying in adverse conditions much safer. Another safety feature is in the Allison dual power system. If one engine stops, the other engine sends power to the failed engine's rotor. The pilot has less power, but maintains control of the aircraft, allowing him to make a normal landing. The V-22 can also be transported efficiently by ship. Its wings fold up for compact storage in a matter of minutes.
The basic V-22 can fly at up to 25,000 feet, so it can fly above the clouds just like real airplanes do, because in fact the V-22 is a real airplane. It has an unrefueled range of over 1,000 nautical miles compared to a helicopter that may have 200 nautical miles. It also has the ability for in-flight refueling, which extends its range forever.
Range can be important, not only for combat purposes.
Disaster relief operations are something that we do quite routinely. A squadron sitting in North Carolina today, for example, could be in Central Africa tomorrow and could be delivering supplies and relief to the troubled people there 6 hours later.
Speed, range, and greater payload. The V-22 is complete. It was accomplished by the unprecedented cooperation of aviation giants Bell Helicopter Textron and Boeing Aircraft, along with many other contractors. They form 72 integrated product teams, from design engineers to shop floor mechanics, to master all the complexities of this most versatile flying machine. But still the question remains, is it an airplane or a helicopter?
This is an airplane that just happens to take off vertically and land vertically like a helicopter. But clearly, it is much more than a helicopter could ever be.
In fact, it's an entirely new species of aircraft, evolved from the combining of 21st century technology with all the elegant concepts ever conceived by the great dreamers of vertical flight.